if you have a right angle triangle, and we know it's a right angle triangle because I have a little right angle thing there, one of the patterns we can find, or that we can see, is that if you make squares out of each of the sides, like this, and like this, the area of the two smaller squares equals the bigger square, the area of the bigger square. And this is something that we discussed together. So in this example, we have 3 squares. This side here is 6 centimeters. And if it's a square, right, if this side and this side are equal to each other, then we know that the area of this square is length times width, which is 6 times 6, or 36 centimeters squared, right? Down here, this square down here, if we know this side is 8, we know this side is also going to be 8, right? And I'll just label this here. This is also 6 centimeters. So the area here is going to be 8 times 8, or 64 centimeters squared. And to find the area of the big square, well, we know that this is 36 and this is 64. Remember, the pattern is that the two smaller areas have to add up to the bigger area. So if we add 64 plus 36, we get 100. Or if we see that this side here and this side here are both equal to 10 centimeters, because it's a square, we know the area here is going to be 10 times 10, or 100 centimeters squared. So that's just a quick review of the pattern we found with right angle triangles. How do we actually use this to solve problems? Well, for example, let's say we're trying to find this unknown side of this right angle triangle. And remember, the side that's opposite the right angle, if you look at this little square is like an arrow that's pointing to the opposite side, that opposite side is called the hypotenuse, the long side of a right angle triangle. It's always the longest side of the right angle triangle across from the right angle, right? So if we're trying to find that length, let's use the relationship that we understand about right angle triangles. And that's that the area of the smaller squares, if you make squares, are going to add up to the bigger square. So I'm going to draw the squares. I'm going to just do a quick sketch here. They don't need to be accurate. But that square and that square are going to add up to the area of this square. So this square down here is going to have an area of 9, right? Actually, you know what? I'll just show the calculation. So it's 3 times 3, which equals 9. So that's that area. I'll put area equals. Here, the area is 4 times 4, which is 16. It's unit squared. It doesn't give us units in this question. So what must the area of this square be? I know I didn't draw it as a very nice square, but that's fine. Well, we know it's the two areas of the smaller squares added up, right? So what's 9 plus 16? 9 plus 16 is 25. So that means the area of this square has to be 16 plus 9, 25. So that's the area of this square. Now, if we know the area of the square, that's not our answer, right? We want to know the side length of the square. So if we know the area, remember area for a square is length times width. But in a square, the length and the width are the same thing, right? That's what a square is. So we can say it's side times side instead, right? That's easier. Or even easier, remember, if we multiply something by itself, that's like saying something squared. So we can write this as s squared. So the area of any square is just the side length squared. But if we're given the side length, if we're given the area of 25, how do we find the side length? Well, we're trying to find out what equals something times itself is going to equal 25. What times itself is going to equal 25? And the key here is that the opposite of squaring something is taking the square root. So to find the side length, we're going to do the square root of the area. And your calculator should have a square root button, or maybe you know the square root of 25 off the top of your head. But the side length, in this case is called c. C is just going to be the square root of 25, right? Which equals 5. So the length of that missing side is just 5 centimeters, or 5 units, whatever the units are. Okay? So what I want you to do is I want you to pause the video here, try this next question, the your turn question, see if you can figure out what that length is down there. When you're done, unpause it to see if your answer matches mine. Okay? Pause here. All right, let's just quickly run through the solution here. First, I'm going to start by drawing my squares. Square for each side. Right? And let's start off with the areas that we know. So the area of this square is going to be 21 times 21, or 21 squared, right? And if I do that on my calculator, 21 squared is 441. And I can do the same thing for the area of this square. 20 times 20 is 400. So the area of the biggest square is going to be the sum of those two smaller squares. And we know it's the biggest square because it's the longest side, and it's the side opposite the right angle, right? So the area of this square is 441 plus 400, which is 841, right? And if we know the area of this square, we know the side length of a square is going to just be the square root of the area. So all we have to do to find the side length, or c, it's just going to be the square root of that area, square root of 841, which is 21. No, sorry, that's wrong. 841. Square root is 29. 29. I jumped the gun a little bit. 29. So that means the side length here is 29 units. So you see, it's not too bad. Find up the areas of the smaller squares, add them up, and then take the square root of the area to find the side length. So I want you to try these two questions down below. Try them yourself. Pause the video here, try them yourself, and check the answers with the answers at the bottom. Round to 2 decimal places. Okay, so hopefully you've done that. We're going to move on to the next examples. So this says, part 2, can you find the length of the shorter sides? And let's try to do the same thing that we did for those previous questions. I'm trying to find this length here. So let's start off by, finding the area of some squares. So I'm going to draw the squares for each side, right? The squares that correspond to each side of this right triangle. I know the area here is going to be 5 times 5, which is 25. I know the area here is going to be 13 times 13, or 13 squared, which is 169. So what's going to be the area of this square? Do we just add these up? Well, this is where we have to be careful. Which is the biggest square? The biggest square is the one that goes along with the longest side, or the hypotenuse, right? And we can tell which is the longest side because it's opposite that little square in the corner, right? So this is our longest side, our hypotenuse. I'll highlight it in yellow to show you that this is the hypotenuse. That means the largest square is going to be this square. So if we know the largest square and one of the small squares, how do we find the other one? Well, we know this is the total, right? Think of this as the total of these two numbers, whatever these two numbers are. So if we know the total and we want to find what's remaining after we remove this, we subtract, right? So we know the biggest area, we want to subtract this to find that area there. So the area of the smaller square is going to be 169 minus 25. 69 minus 25, which is 144. Right? And we can always check, does this make sense? Do the two smaller areas add up to the larger area? And they do, right? 144 plus 25 is 169. So we know the area of this square is 144. How do we find the side length? Well, again, we just take the square root of the area. So b is going to be the square root of 144. Sorry, that was a bad square root. And you could use your calculator, or maybe you know the square root of 144 is just 12. So, just to refresh, the key to doing a problem where you're trying to find one of the shorter sides, the length of one of the shorter sides, is that you always have to identify the long side, and I like highlighting it so we know which one's the long side. You subtract the smaller area from the largest area to find the remaining area and then take the square root. So I want you to try this question yourself. Pause the video here, try it yourself, and then I will unpause it and reveal the answer. So just looking at this, I found the areas already of the two that we know, right? I just squared this and squared this. So which side is the long side? Well, I know that this side is the long side. First of all, it looks the longest, but it's also across from the right angle, right? If you picture this right angle as an arrow pointing at the long side, that's the long side. So because this is the long side, how do we find out the area of this square? We have to take the largest area, which is 151.29, and subtract 56.25. So do 151.29 minus 56.25, and that gives us 95.04. So this area is 95.04. And then to find b, or to find our missing side length, we do the square root of that, right? The square root of 95.04. Which gives us an answer of, it's like 9.748846, blah, 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 blah. So I'm going to round that to 2 decimal places. It's usually a good idea. 9.75. That's the answer. There we go. So what I want you to do now is I want you to try these last 2 questions on the page, and then there's more practice questions on the following pages. Try those as well. All right? Good luck.